Okay, we're going to take a few minutes to look over this content and review for your part 2 of this chapter's exam on chemical reactions, and which will be, of course, tomorrow. And then on Wednesday, we'll start your final chapter, which is organic chemistry, which would include compounds like this, which we see down here, but we'll address that at a later time. And what this includes is being able to finish equations. I think that's perhaps sometimes the most difficult to do. And with that, here, there's only one word equation. And what I would hope is if you have a really good understanding of this, you'd be able to determine which one of these 5 equations are a synthesis, a single replacement, a combustion, a double replacement, and a decomposition. Okay? So go ahead and take some time to go ahead and write them compounds down, or those reactions should you choose to follow along, as we asked you to tune into excuse me, the science channel. So I'm just going to go ahead and hit pause so you have that opportunity to do so. Okay. So now as we proceed, your 5 choices, again, are as follows. It's either SY for synthesis, or the opposite of that, decomposition, single replacement, double replacement, and then combustion. Okay? Each one of those, we tried to give you a little bit of insight on why which equation follows a specific pattern and what's actually happening within that. So those are your choices. And we've been doing this for quite a while now, so I hope we have a good understanding of this. So I'm going to go ahead and erase that now. And if you have made your determinations, this is what it would be as follows. We have 2 compounds coming together. That is a synthesis reaction. Okay. Here we have 2 complex compounds. Okay. A compound here and a compound here, which means that's going to be a double replacement. Okay. Here we just have a diatomic molecule and an element. So those 2 again are just coming together to form a more complex substance in a synthesis reaction. Here we have 2 distinct compounds. Okay. In this case, we have, what would you think that is? And if you said a single replacement, that would be correct. This is the best indication of why that is, because you have a metal all by itself. Here we have a compound. So therefore, this is a single replacement. Here you have 2 distinct compounds, making that a double replacement. Okay? And in this case, we just have 1 compound by itself, which can still be part of the reactant side. So what's going to happen is this would split apart, making that a decomposition reaction. And then finally, we know that this is a combustion reaction because we have a hydrocarbon, hydrogen and carbon, reacting with oxygen to give us 2 distinct byproducts, or products on the right-hand side. So what we see forming over here, from the top down, we've got calcium being in column 2, so it is a +2 charge. Bromine being a halogen, being a -1, so therefore we need 2 of those. The least common multiple is 2. 2 divided by 2 is 1. 2 divided by 1 gives you 2. Okay, and then notice halogens and gases. Here's a gas and here's a halogen. When they're by themselves, those are diatomic. So nothing has changed here. We've got 1 calcium on each side and 2 bromines on each side. So that is balanced. Sometimes that happens. You just get 1, 1, and 1. Okay. On this equation, this double replacement, I want you to think which one, if any, of these subscripts are going over to the product side. Okay, we spent quite a bit of time on that on if or why that may happen. So if you want to take a little bit of time between what we've talked about so far and what is coming up as far as content, I would suggest you hit the pause button to go ahead and finish these reactions as we are proceeding. Okay, so again, the question would be, is any of them subscripts going over to the product side or right side? And the answer to that would be yes. Okay, should probably make that look like it's actually a capital letter. Okay, so what we see happening in a double replacement, it breaks apart between the positive and negative ion. So in this case, the only one we can determine for sure that is going over to the product side is this 4, because that 4 is tied in with the phosphate ion. Okay, so again, it splits here between the positive and negative ion, and here between the positive and negative ion. Phosphate has a charge of -3. Hydrogen is +1. So +1 times 3 is +3. 1 phosphate ion times -3 gives you -3 in that sense. Okay? Here, 1 hydroxide ion has a charge of -1. And we've got 3 of them. So therefore, this side, the negative side, we've got 3 hydroxides, means this whole thing has -3 charge. By taking -1 times 3 gives us -3. And to add up to 0, think about what does nickel possibly have for a charge. It can be +2, it can be +3. So, since the entire right side is -3, and we only have 1 nickel atom, or 1 nickel ion, however you want to refer to this side of the compound, means this has to be a +3 charge. Now we got that adding up to 0. Okay, the charges will not change going from one side to the other. So upon what happens is, remember, this is the only subscript that's going over there for sure. This one might, okay, and this one might. It just depends upon what it is that we need to have the compound add up to 0 in its charges. So let's go ahead and write H, okay, because that's our positive ion, okay, +1. And then what do we have left over, which is OH. So if you want to write it like this, you can, okay, because we're forming water. Or if you look at it in this sense, we still have an OH molecule. This is still water. You're just showing it in a different format. You've got a positive charge of 1 and 1 hydroxide ion being -1. So that now adds up to 0. Okay, so what do we have left over? The positive ion for nickel, which is +3. Because remember, charges do not change. And then we've got the negative ion of phosphate. So that is PO4, which again has a -3 charge. So notice what had happened is, if you decide to write this as water as H2O, we've got 2 hydrogens. Okay? Here we had 3. Because remember, that was the only subscript that came over to this side for sure, because it's part of the formula. This adds up to 0. 1 nickel atom +3. 1 phosphate ion -3. That now adds up to 0. So now we can proceed balancing that chemical reaction. Okay, so we'll go ahead and I would suggest that as we go through these, hit pause as we start a new reaction, so you can try that on your own. Then, if you need extra help, then you have that opportunity to ask that question. Okay, so in this case, what you might want to do, we can help you get set up here. We've got nickel on each side, we've got hydrogen on each side, we've got hydroxides on each side, and we've got phosphates on each side. Okay, so again, we'll just help you get set up. We've got 1 nickel to 1 nickel. Okay, we've got 3 hydrogens on the right. Okay, no, we broke this apart. Sorry, that is incorrect. We've got 1. Oh yeah, we've got 3 hydrogens. I'm thinking of the product side. We only have 1 over here. That's that hydrogen. We've got 3 hydroxides on the left. We've got 1 hydroxide on the right. We've got 1 phosphate on the left and 1 phosphate on the right. Okay, so that's how you would want to go forward and proceed working on this. So perhaps the best place to start when you're looking at these is we've got 3 hydrogens to 1. Okay, so let's try putting a 3 here. Remember, this is split apart here. So 3 times 1 gives you 3, so that's now balanced. Remember, that's a hydroxide ion. 3 times 1 also gives you 3. So in this case, it looks like we have that balanced now. And we can double check. Even if you had decided to, per se, split these apart, okay, we could say hydrogens, phosphorus, and oxygen, for those of you who maybe want to keep them separate rather than together. Okay, so that's 3 hydrogens, and then we've got 2 over here. Okay, 1 there and 1 there. So for oxygens, we've got 4 and 3, gives you 7. Okay, and over on this side, we only have just the 1 oxygen here and 5 there, or 4, giving you 5 then. And then for our phosphorus, we have 1 there and 1 over here. Okay. So, upon doing this, I see I have goofed again because we've got 3 hydrogens and 3 hydrogens. We need to actually make that 6. Okay. So now that we got these split apart, we can say 3 times 1 is 3, and 3 times 1 gives you 3 again. So that gives you 6. Okay? Then our phosphorus hasn't changed, but once we've done this, when we put this 3 here, 3 times 1 gives you 3, and then we've got those 4 over there giving you 7. Okay? So then on this side, we've got, nope, I got that on the wrong spot. Meant to put it here. Oh, there's a 5 there. Now it's 7. So now we've got the equation balanced. Here, you're splitting the elements apart. Here, you're keeping the polyatomic ions together. Same process, same answer. Depends how you want to approach that. Double replacement reaction. Okay. So this next one, which we had already established as a single replacement reaction, okay, and it's a word problem, so you need to be able to write these out, okay. This says cobalt. The symbol for cobalt is CO, okay, and then we've got nitrate, which is NO3, okay, and again, we spent time on this in class. You perhaps laugh. We're going to see that mistake because people are going to associate that Roman numeral 3 with this number down here. So please don't do that. You may have to put a number down here, and it may be number 3, but this is its charge, not the number. Nitrate has a charge of -1, so this is 1 nitrate ion, okay, with a charge of -1. This cobalt, which has multiple charges, but this is telling you it's a +3, that does not add up to 0, so the least common multiple between 1 and 3 is 3. 3 divided by 1 gives you 3. 3 divided by 3 gives you 1. 3 divided by 1 gives you 3. So we need 3 nitrate ions. We've only got 1, so we need 3 of them. Okay? Then the symbol for lithium is Li, and it's in the first column. That's why we had chose not to put a transition metal on there, or one that has multiple charges. We don't need to write the charge on here, which again is +1, because it's in the first column. So in a single replacement reaction, this is going to replace the positive ion here, which is the cobalt. Okay, so that gives us lithium plus NO3. And that 3 is coming over here because it's part of the formula. It doesn't necessarily mean that this 3 is, because it's not, because this was to balance out the compound. Remember, this is -1, and that's +1, because these charges will not change. Okay, that's now added up to 0, and all we have left is cobalt, and we're not concerned about what the charge of that is because it's by itself in this single replacement reaction. So again, what you need to be able to do, okay, is now balance this. Okay, and again, if you have to hit pause, I would suggest that you do that. We'll just go ahead and do the math, and then you can go back and see perhaps where you may have made a mistake. Okay, we've got 3 nitrate ions here and only 1 nitrate ion here, so we'll go ahead and put a 3, distribute that through the entire compound. So now we've got 3 nitrates, 3 nitrates. Okay, we've got 3 lithiums to 1, so we would put a 3 here, and then there's a 1 in front of here. We're just going to leave it as a 1, and then we've got 1 cobalt over here, so we can leave that as 1. So we have 1, 3, 3, 1. I should have done that for up here. We've got 1, 1, 3, and 1. Okay. Then we've got this decomposition reaction. Again, I'm trying to move this along because we're up to 17 minutes. Okay. We have a decomposition, which means that's going to break apart. And in that case, it would break apart right here. So that gives us sodium plus nitrogen. Okay? And what we see happening is, will this subscript come over here? Well, maybe. But notice when a gas is by itself, or a halogen, here's a halogen, it's diatomic. Here's a gas, it's diatomic. Here is another gas, and it's by itself. So you need to put a little 2 there, because nitrogen's also diatomic. Okay? So nitrogens come in pairs. This is an odd number. We need to get that up to an even number. So what we do is we take that times 2. That gives us 6 nitrogens. We only have 2 over here, so we'll take that times 3. And then with 2 sodiums now, we'll put a 2 here. So our subscripts are 2, 2, and 3. Okay? Then, for combustion reactions, I want you to think about what are the same byproducts that you get, okay, every time in a combustion reaction. Okay? And if you had said carbon dioxide, that is one of them, and then water is your other byproduct. Okay, so we've got carbon dioxide and H2O. Now, it doesn't do you any good to write it as HOH like we did up here, because we don't have a hydroxide ion over here, so that will not help us out. The next thing you're going to want to do is look to see, okay, is that hydrocarbon, hydrogen, carbon, here's your hydrocarbon, is that an odd number or an even number? Because remember, if this number is even, okay, you're going to want to double that. But since it is an odd number, we can just go ahead and put 7 over here. We don't have to double that. Okay, put a 7 in front of the carbon dioxide, or CO2. Then let's move on to your hydrogens. You've got 16 to 2. So we're going to take that times 8. So now our hydrogens are balanced, our carbons are balanced. Now we got to do our oxygens. Okay? 7 times 2, 14. 8 times 1 is 8. Okay? You add them together, that gives you 22. Okay? I don't know why it looks plus. That's what I meant to write. So 14 plus 8 gives you 22 for oxygens. 22 divided by 2 would give you then 11. So your 4 subscripts are 1, 11, and then 7, 8. Okay. Now, should this possibly be an alcohol on here, okay, which means it ends in OH, that is still a hydrocarbon. You can visualize it as that, and that still pertains if this is even or if this is odd, okay? So if we have this as an even number, okay, then if we have C16 and H34, okay, those are big numbers, I get that. You're going to want to double that right away because this number is even, which means you're going to put 32. That's why you have a calculator if you chose to use one. Okay. If you choose to go on and balance that reaction, that's entirely up to you. Those are 5 reactions, how to classify them, and how to finish them. Okay? I think we're not doing too bad for time. I see it says 22 minutes, so we'll stop there. So exam part 2 tomorrow, and then we start the organic portion or your final chapter on Wednesday. So tune in next time. We'll catch up to you on, well, Tuesday, finishing that exam, but then on Wednesday, hopefully we're here in school. But also, if we are not, tune in to the Science Channel again to keep us moving. So hopefully we can keep everyone current with this content. We'll catch up to you next time.